We're now going to look at example B on page 472. So I wanted to go over some of the information that completing the square can help us with when we are looking at solving quadratics. So completing the square, it says, is useful to help analyze specific features of quadratic functions, such as the maximum or minimum value and the possible number of zeros, which is another way of saying the number of solutions, or it's where our graph crosses the x-axis, okay? When a quadratic equation is written in the form y equals a times x minus h squared plus k, you can determine whether the function has a maximum or a minimum value based on a, and what the value is based on k. This information can also help you determine the number of x-intercepts. Okay, so I'm going to help you understand what all that means. First off, if you look at this form of the quadratic, we've seen that form before. It has a specific name. It's called vertex form. Okay, it's vertex form of a quadratic. And we've looked at vertex form of a quadratic before whenever we were doing transformations. Remember, we were talking about what A tells us. If A is positive, it opens up. If it's negative, it opens down. H and K are also specific too, because that's actually your vertex of the function. Remember, we take the opposite sign of what H is, okay? That's our X value of the vertex, and K is the Y value of the vertex. So just by looking at the function in vertex form, we'll be able to tell if our quadratic opens up, down, whether it's a max or a min, and how many times it's going to hit the x-axis. So I'm going to start with example B. It tells us to analyze the quadratic function y equals x squared minus 6x plus 13 by completing the square. Okay, so step one tells us to complete the square on the right side of the equation. All right, so I'm going to copy down the equation right here. So we've got y equals x squared minus 6x plus 13. I'm actually going to drop off the y equals, and I'm going to set our quadratic equal to 0 so that we can solve by completing the square. Okay, so let's think about the steps we did on the other page. I'm going to start by isolating the variable terms. I'm going to take that 13 and I'm going to move it to the other side. So that gives us x squared minus 6x equals negative 13. I just moved the 13 over to the right-hand side. The next step is to complete the square. All right, remember when we complete the square, we're doing b divided by 2 squared. All right, so I'm going to come over here and I'm going to put x squared minus 6x plus something equals negative 13 plus something. Okay, so look at B. B is negative 6. Negative 6 divided by 2 squared. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm going to fill in 9 on the right-hand side. We just made a perfect square trinomial. I also have to add it to the other side because what you do to one side, you have to do to the other. Okay, let's go ahead and factor our perfect square trinomial into a binomial squared. So factors of 9 that add up to negative 6. Well, that would be negative 3 and negative 3. So since our binomials are both the same, we can write them as a binomial squared. So x minus 3 squared equals negative 13 plus 9 is negative 4. Okay? Now to put this in vertex form, we're going to do a couple little things. First off, we're going to take the negative 4, we're going to move it back over here to be with our binomial squared. So I'm going to have x minus 3 squared. When I move this negative 4 over to the other side, it's going to become positive 4. Okay? And I'm actually just going to go ahead and put the equal sign and our y back in the front of our quadratic. Okay? Now at this step, like, we're going to stop. We're going to stop at this point because we have completed this square and we are now in vertex form. Okay? We're in vertex form, and we want to stop there because we want to take a look at what is vertex form telling us. We could continue on and we could solve by using the square root method, but we're going to stop right there because vertex form tells us a bunch of interesting things about this quadratic, okay? So in step 2, it tells us to identify the direction of opening, whether the vertex represents a minimum or a maximum. So we can get that information by looking at what A is. Well, A is always right here in front of our parentheses. And since there is no number in front of the parentheses, it's understood to be a positive 1. And remember, if A is positive, what does that tell us about our quadratic? It tells us that it's going to open up, okay? So we know first off that it opens up. It's gonna look like this, okay? So that's what we know just by looking at that vertex form right there. So if our quadratic opens up, it asks us to identify whether the vertex is a maximum or a minimum point. If it opens up, we're gonna have a minimum point, okay? All right, so that was step 2. That was step 2, okay? So it's going to open up and we have a minimum point. Step 3 tells us to determine the maximum or the minimum value. Determine the maximum or the minimum value, okay? Well, in that case, we want to figure out, that's basically just asking us what is the vertex? The vertex itself is the maximum or the minimum value, okay? Well, if our quadratic is in vertex form, we can find the maximum or the minimum value by looking at HK. Remember our ordered pair HK. So HK in this situation right here, here's H. H is -3. But remember when we plug it into our ordered pair, we want the opposite sign of what H is, okay? Because if we multiplied this quadratic out, we'd actually get the opposite sign. So instead of -3, we're going to put +3 here for H, and K is a positive 4, okay? So our vertex is at the ordered pair 3, 4. This is our vertex right here, and we know that it is a minimum. We determined that right here in the previous step, okay? So well, actually, I want to show you this. I love this little stamper right here, and I haven't gotten to use it in class very much, but I'm going to use it today. I've got a little coordinate plane right there, and I'm actually going to graph the vertex for you because I want you to have a visual. So at 3 and then 4, 1, 2, 3, 4. So this would be the vertex of our function, and we know that it opens up. The quadratic opens up, something like this. Now you have this picture on your pages in front of you as well. Okay, and I wanted to show you this because look at step 4. What is step 4 asking us to do? It's telling us to determine the number of x-intercepts, okay? Well, folks, if the minimum value, look, this is 4 right here on the y-axis. If the minimum value is at 4, how many times does this quadratic touch the x-axis? None. It's not going to touch it at all, right? So determine the number of x-intercepts. Well, there are no x-intercepts, okay? There aren't any for this one, okay? Now, step 5 tells you to verify by graphing, okay? So step 5, verify by graphing. You don't have to have my fancy little stamp right here, although you can get it on Amazon for like 12 bucks. It's pretty amazing. But you can graph it just like that, okay? From there, we're going to do a couple of practice problems that are located at the top of page 473. So click on the next video when you are ready.